Hello and welcome to Gelologic. Today's topic is task and goals. I've noticed that typical tutorials are focused on the small logic implementation details, which is not bad if you are familiar with the software development process. But this can be a trap for beginners because it forms a wrong impression about what are your deliverables. AnyLogic tutorials, unfortunately, are not different. On other hand, everybody understands that before you start any project, you should have a clear vision of what you want to achieve. Without it, you will just waste your time and money. This is general rule for any type of project. So what does this mean in a world of simulation? To figure out answer, I will build a very simple model of park entrance. A primitive algorithm for this consists of three steps. Person arrives at the entrance, waits patiently for the service. The service means waits in line to show the tickets. And third person actually enter to the park. We need to add two additional components for our simulation, person source and person thing. Okay, what we need to add the visual component target line where everything start. After that we take the pathway, make it straight. We take the service line. We just took the one here. We need to put second target, it will be park entrance. First, we just follow the road. Here our path. Service is actually service. Everything is on place. Now we can run it, accelerate a little bit, and to join the show. Persons coming, form the line, show the tickets, and actually enter to the park. Are we done with the simulation? Not at all. We haven't even started because we didn't think about what we want to achieve. Yes, we built a checkpoint model, but why did we do that? Who is going to use our model and what do they want to see as a result? Maybe you don't need a model. Just simply multiply the rate, how many persons per hour enter the park by the time. Maybe your customer want to see distribution of how many adults versus kids visit the park. You obviously don't see that. So it means throw away what you have done and now do what the customer want. For example, we are lucky. Our customer, park owner, likes our checkpoint model. But he specifically want to know how many people are enter the park. On one hand, you can say, "Oh, I'm done. Just look at this small number near the sink." That's exactly what you're looking for. And your customer will be, let's call it, unhappy because first, this is not user friendly since your customer need to understand any logic flow chart. He simply need to see the data and understand this data. But most importantly, when the simulation stops, let's stop it, the result will be lost. Now you don't see how many people actually visit the park. Let's make a couple enhancements. I will place label on the screen to reflect number of the people who have gone through the checkpoints. Switching to the presentation, grab label, text. We need to change to dynamic sync. This is the name of this object. Dot control space help us to find what we need. That's exactly what we need. Return total number of pedestrians passed through this block. To make it more readable, just place count. As you noticed, it's pretty small, so we're going to appearance. Here we change like 26. Yeah, I think this would be enough. Let's see how it's changed. Accelerate a little bit. Now we see the count actually changing. It reflects this number, but when we actually stop, it's still disappear. To show the result after the simulation stops, we need to add some UI on experiment screen. Change to the projects, double click on simulation. AnyLogic provide different type of experiment, but by default it uses the simulation experiment, which show the model visual representation. Usually tutorials do not bring your attention to the fact that experiment screen is the final point of your model execution, but it is. This is where you should define your post-experiment action. Here in the properties tab, you could find under the Java action, you can find the field after simulation run, where you could define all your post-experiment activities. Grab one more label. I'll put the 26 size. Click on the screen to see properties of simulation, and here we're gonna put the text 1. This is, as you see, this is name of our text. That we're gonna use function set text. We'll use root text get text. So I'm not doing anything fancy, just display the final count. This is not practically user-friendly interface, but it's better than nothing. Note that to access element on the screen, I need to use word root and after that name of our element. Now we can run simulation, accelerate, stop it, and actually see the result. Are we done? No, because we have not thought about how our customer is going to use the simulation. Right now, our simulation is like a movie. You can restart it multiple times, but none of the actors' behavior changed between runs because the condition didn't change. We need to provide tools for changing start condition. This is a critical point of development. Just take a look at the agents which are used in the current model. All values is hard-coded. You see this value? Everything is hard-coded. Nothing changed between runs. So model should be changed to take parameters instead hard-coded value. This could be very tricky for the complex task. To simplify our life, let's add only one parameter, the diameter of the circle that represents the size of person in the model. Go to the source, replace it by our parameter. I'm gonna set up default value as 0.4, which is roughly the same as the original hard-coded value. We can run the simulation to see that nothing really changed. Now we need to add UI to provide a way to modify the model parameters. So we are going to experiment screen. Yes, experiment screen is a start point. Don't forget to uncheck this checkbox. You can think about experiment and AnyLogic as the wrapper for the whole simulation model. Start and end point. Let's add some UI for configuring the input. Place the field. We need to go to the presentation. Place the field. Don't forget the size. Okay, what we need actually to simplify our life, we're gonna put the variable and we connect this field Now we need to add most important part. In the properties tab for the experiment, we have section parameters. Here we have our diameter, our variable names. Don't forget to put default value for the variables. Let's have the same 0.4 and run it. Now we actually ready to run it. Accelerate a little bit. It works. Now we can stop, change value like 0.7. As you see, circles become bigger, but you don't really see any changes in behavior. Let's change diameter to the 1. That's actually the purpose of simulation. Run it multiple times, changing the condition all the time. Now behavior is a little bit changed. You see, right now we run it 3 times, changing our condition, and we got 2 different pictures. Picture for the value 0.4 and 0.7 was pretty close, but right now we have pretty strange crowd. So what you should learn is the goal of simulation is not to create a model. The goal is to create deliverables which meet the customer expectation. To meet expectation, you should have a clear vision of how your end users want to use your model and what results he is expecting to see. Third, your development should have 3 major tasks. A. Design a start screen for inputting the model parameters. B. Develop a model based on those parameters. C. Design the output. And remember, visually separate the output from the input since they are on the same screen. This video was just an introduction to what you should think about before beginning development of the simulation. Once you get started, there are many other concerns to take care of, like distributing the data and making the model user-friendly, which may be covered in a future video. Hope this was helpful. If you have any questions, feel free to leave a comments.